In this video, I'll break down the different types of slowly changing dimensions like type 1, type 2, and type 3. Also, in this video, I will talk about other data modeling stuff like primary and foreign keys, differences between star and Snowflake schema, and much more. Stay tuned! Welcome to the video. My name is Alex and on this channel I cover Microsoft Fabric and Azure related topics. In this video, we will continue our DP-700 exam prep series and link to the entire playlist can be found in the description. This is the episode 14 in this DP-700 exam prep series, and in this episode we will cover fundamental concepts of data models and especially focus on slowly changing dimensions, since understanding those is one of the key topics in the DP-700 exam. Like in every episode in this series, we will first start with the theory section, followed by demos/tutorials on Fabric, and then we end the episode with few questions related to topics covered in this episode, so that you can test your knowledge. But now, let's get started. First, let us talk about why we even do data modeling. When we collect data, it is usually messy. It might come from many different systems like databases, CSV files, APIs, or even manual Excel files. If we try to use raw data like that for analysis, it becomes very difficult and very slow. So, we do data processing and data modeling to organize the data into a clean, structured format. This makes it easier to find answers to questions later and use that data to all kinds of use cases. Good data modeling also improves performance. Queries run faster because the system knows how the data is related and stored in the optimized way. It also ensures data quality. When we define relationships and rules, we avoid problems like duplicate records and missing information. Also, data modeling supports business goals by aligning the data to real business processes like sales, inventory, or customer management. Other important reason is scalability. When the amount of data grows over time, a well-designed data model can handle it without problems. Also, a key thing in data modeling is to reduce data duplication by normalizing the data in a way that same things do not repeat over and over again in the data. And in upcoming slides, we are going to cover what this normalization and denormalization means. And finally, data modeling makes it easier for developers and analysts to work with the data and create reports, and this way provide value to the business. That is typically the end goal here. So, what exactly is a data model? A data model is like a blueprint or a map of your data. It defines the structure of the data, meaning how the data is stored, what tables exist, what columns are inside those tables, and how the different tables are related to each other. Here on the screen we can see two tables, customers and orders. That could be part of some simple data model. Key concept in data models and data modeling is to define relationships between tables or views. For example, in this case, a customer table has to be connected to an order table so that we know which customer placed which orders. This is done using keys. First, a primary key is a column that uniquely identifies each record inside a table. For example, customer ID in the customers table or order ID in orders table. Each customer and each order has a unique ID that can be used to identify each row. Second, a foreign key is a column that links one table to another table's primary key. For example, the customer ID in the orders table connects back to the customer table. We can then use these keys to join these tables together. Of course, we could also have one big table named, for example, customer orders, and repeat those customer names and countries in each row, but then we would end up with a lot of repeating data in our table, since the same customer could be doing multiple orders. That's why it is good to reduce that repetition by normalizing the data. Here on the screen we can see the example I just described by having that larger customer orders table where we repeat customer information each time a customer makes an order. Then below that we have a normalized version of that same data where we have split that data to two tables so that we can reduce the amount of data repetition. In this case, we would normalize that one big table to one fact and one dimension table. So let's talk about the concept of facts and dimensions next. In the world of data modeling, we often divide tables into two main types, fact tables and dimension tables. Fact tables store measurable data, meaning the numbers we want to analyze. For example, sales amounts, number of products sold, and profit amounts. Facts answer questions like how much did we sell or how many products did we sell. The fact is usually the central table in a data model. Then we have to use foreign keys to link fact table to dimension tables. Also, it is good to note that typically fact tables tend to be way larger than dimension tables due to their nature. Dimension tables store descriptive data, meaning the context for facts. For example, information about customer, products, stores, or dates. Dimension answers questions like who made the purchase, what was bought, and where it was bought. Relationships are then created between fact table and the dimension tables. For example, customer ID links orders to customers and product ID links orders to products. When you hear about star schema or Snowflake schema, they are based on this idea having facts in the middle and dimensions around them. And next, let's talk about those two types of data modeling schemas that are the most typical ones used in the analytical use cases. When we design a full data model for analytical use cases, we can use different types of structures. Two of the most common ones are star schema and the Snowflake schema. In a star schema, the model is simple and flat and resembles a star in a way. The fact table is at the center and then the dimension tables are directly connected around it. In Snowflake schema, we have more structure since dimensions could be split into multiple tables. Thus, dimensions in star schema are more denormalized compared to the Snowflake schema. Because there are fewer joins between tables in star schema, queries tend to be faster when compared to Snowflake schema. However, star schema can take up more storage because some data may be repeated. Also, it can be argued that star schema is easier to use since the structure is simpler. Thus, in my opinion, it is better option for simple reporting and dashboards. Snowflake schema is then better for more complex cases where you have, for example, changing dimension data. And to one more time highlight the differences between these two, you can think about that in star schema we just have one big customer dimension table that tells all the information about customers. In a Snowflake schema, we can split that customer dimension into multiple tables, and one could store basic information about the customer, then one address information, and one region information, etc. Also, there could be some cases when the data in dimensions changes. For example, a person moves to a different country, and that needs to be shown in the dimension table. So, let's cover how we can handle changes in dimensions. Slowly changing dimensions or SCDs is a very important topic for the DP-700 exam and also for real projects. Sometimes the descriptive information in a dimension table changes over time. For example, a customer may move to a new country or change their last name. We need to decide how we want to handle these changes. There are different types of SCDs based on how we manage these changes. In SCD type 0, we do not change the data at all. Even if the real-world information changes, our data model keeps the original values forever. This type 0 is good for fixed data, like a person's date of birth that shouldn't change ever. Also, one classic example is a date dimension that stores date values and more information about dates like which quarter to that date belongs, etc. Then, in type 1, we simply overwrite the old data with the new data. No history is kept. For example, if James decides that he doesn't want to live in the UK anymore and decides to move to Thailand to enjoy better weather, then in SCD type 1 we would just update the row to show that James is now living in Thailand. Of course, since we don't keep any history, we lose the information that James was previously living in the UK. And this information could be important when we look at past orders or transactions that James has made since he used to be an UK customer. And in analytics, we most often look at past data, so in real-world use cases, type 1 doesn't really usually fulfill the reporting needs. For tracking history, we can use SCD type 2. In this type 2, we create a new row when something changes. Each row has its own start and end dates so that we can know when that row was valid. This way we can keep track of the full history of how data has changed over time. There are many variations in how the change tracking can happen in SCD type 2, but one very typical way is to use start and end dates and maybe have a current flag that indicates is the row current or past version for easy filtering. Also, in this case, we can't use the customer ID as the primary key for table since we could have duplicates for it, as we can see shortly. Thus, we can, for example, create a surrogate key that is always unique and then use it to link the SCD2 data to the fact table. But as I said, there are many ways how SCD type 2 can be made, but the key thing to remember here is that we track changes on their individual rows and add new rows when something changes. If we repeat the same situation that we had with James, that he moves to Thailand from UK, in type 2 we would then create a new row and end the previous version of that row and start a new row from the same date as the previous one ended. Also, we have a new surrogate key for the new row, since now we would have a duplicate in the table if we would use the customer ID as the primary key for this dimension. Then we have type 3. In this, we store the previous value in another column inside the same record. For example, we can add a previous country column. When the country changes, we move the old country in the previous country and update the current country. Type 3 is good if we only care about tracking the last change, but not full history over time. In the case of James, the table would look like this after he moves to Thailand. There is also a few other types of SCD, but they are out of scope for this series. But please explore them on your own if you are interested. Next, let's go to Fabric and do a demo/tutorial about these different types of SCDs together to really understand this topic, since, like I said, this topic is very important in the DP-700 exam. Before we open Fabric, I would like you to know that I spent a ton of my free time creating these videos for you, and that's why I would like to hit that like button and subscribe to the channel for more DP-700 and Fabric content. This doesn't cost you anything, and I would highly appreciate that. Also, if you'd like to support the channel with a cup of coffee, you can do so by clicking the Buy Me a Coffee link that can be found in the description. But now, let's go to Fabric. Now we're in Fabric and I have my warehouse open here. I'm going to use the warehouse to demonstrate these different types of SCDs. Actually, we could be also using a lakehouse and maybe Spark SQL or PySpark to do the same thing, but I think that the most people watching this series are most familiar with T-SQL, so we will go with the warehouse today. And here I have this SQL script that I have created to demonstrate these SCDs. Let's start by creating a new schema to this warehouse. So we create a new schema for the episode 14 that we're currently doing here. Then we want to start to demonstrate the SCD type 1. We're actually going to skip the SCD type 0 because that is basically a static table and there is not really anything interesting to demo there. So let's first demo the SCD type 1. So overwrite the existing data and we don't have history in this slowly changing dimension. So let's create a table and then insert few rows to that table and then display that table. Let's run these commands here and then we should see how does the table look. And we should have there 2 rows of data, laptops and headphones. So basically we have some product information here and we are using like this product dimension to demonstrate this SCD logic. And here we can see that we have the product ID, product name, and then we have the price. And next we would like to demonstrate how the change happens in the type 1 SCD. So I would update one of these rows and we're going to update this product ID 1, meaning the laptop, so that we have a new price. Inflation has been high here, so we add 100 euros or $100 to the price. So it will get a bit more expensive. So let's update the product price and then display the data. So this will reflect that how we see things happening in the SCD type 1. So we lose the history about the previous change there. So we don't really store things that have happened previously to that specific item in the dimension. So SCD type 1 is very simple in my opinion, but it doesn't fulfill the use cases in the real world scenarios, since now we don't know what was the product price previously, and if we would like to report things that happened in the past, we wouldn't have that price available here. Next, let's cover SCD type 2. So basically in this SCD, we will add a new record for every change, so we can see the full history for the data. So let's again create a new table, but this time let's have more columns, since the SCD type 2 logic will require us to have more columns typically than in the SCD type 1, since we need to have some logic that we know what is the validity of each row and when it was valid, etc. Also, we will need that surrogate key since we cannot use the product ID any longer as the primary key in a real-world scenario, since we can have multiple rows for the same product that have been valid in different times. So let's create the table for the SCD2 and then also insert the same 2 rows there, but now with slightly different columns, and then we can display the data. So let's run this SQL here, and we can see how does the data look. So we can see that we have the surrogate key, product ID, product name, price, and then we have the record start date, record end date, and is current. And one thing to note about this record end date, that this is just one way of doing the SCD and setting this like a record end date to the very far into the future. For example, like this 1,000 years to the future almost. One other option would be, for example, have these as null values so that basically those are null if there is no later version for that row. Then in many cases we have some type of flag in the SCD2 table that indicates that is that row the latest or the current version of that specific row, so that we can easily filter out the latest version of each row from the table without using these timestamps here. So it will just make the usage a bit easier. And now let's simulate the situation that we had there previously, that the laptop price will change. So basically we will first update the first row and set it as inactive, and we will set the end date for it, and then we will update the current flag to be 0. And then we insert a new row to that table that is valid. And now let's run these 2 steps and let's display the data so we can see how does the SCD2 logic works. And now we can see how does the result look after the update. So we have now there the product ID 1 2 times, meaning that we have 2 rows for laptops here, but we have different prices. And we can see that this first row here was valid previously, but it is not valid anymore, and it has ended now. And then we have this new row that is valid from the same date as this previous record ended, and that is valid for that like 1,000 years into the future. And there we can see that the isCurrent flag is also 1 for that. And now we have this one where the isCurrent flag is 0. So it would be very easy for us to filter now the current versions of the data if we would like. Next, let's cover the SCD type 3. And in this type, we track the previous value, but we don't have the full history. So let's create a table for the type 3 and then insert those same 2 rows there and then display that data. And I will explain the columns to you shortly. So now we have a similar table that we had in type 1. So we have the product ID, then we have the product name, then we have the current price, but we also have this column previous price. And this current valid from tells the date from which onwards this current price is valid. So we can see that these have been valid since January. And now let's simulate the situation where we again change the laptop price here. So now we would update the row and we don't actually insert any new rows to this SCD. So we will set the previous price to be the current price and then update the current price with the latest price. And then we change the current valid from to this date. So from this date onwards, we can see from the table that this price has been valid. And let's run that update and then display that data to see that how that works. And here we can see how does this look now. So we don't get any new rows to the table, but we have this previous price now for the laptop. And then we also have the current price. Then we have also updated the information that this current price has been valid from this date onwards. But as you can see with this SCD, the history tracking is quite limited and we can only see the previous value. And in many cases, many people don't even add this current valid from to this table. So basically we got very little information about the historical changes. And actually I have to admit that I have never used the SCD type 3 in a real world scenario before. But type 2 I have used so many times that I cannot even count, because it is the most typical one to use. Next, let's have a couple of practice questions about these different types of SCDs, so that we can make sure that you get every question correct in the exam about these. But before we do that, I would like you to know about this website called certiace.com that I have created with few friends that offers free custom-made practice questions to certification exams like DP-700, DP-600 and also DP-900 is coming very soon. Here you can practice to those exams and use these custom-made practice questions to test your knowledge. But now let's have those two practice questions. Let's have our first question. A data engineering team needs to update a product dimension in Microsoft Fabric Warehouse. When a product's price changes, the business requires that the current price must be updated, the previous price must be stored, no full historical tracking beyond the last price is needed. Which slowly changing dimension type best matches this requirement? A. SCD type 0, B. SCD type 1, C. SCD type 2, D. SCD type 3. Now think about the answer for a moment and pause the video. I will reveal the answer in 3, 2, 1. The correct answer is D, SCD type 3, since it fulfills these requirements the best. Type 0 and 1 don't store history, so they won't work. Type 2 would technically work, but since the requirements say that no full historical tracking beyond the last price is needed, the Type 3 is a better option than Type 2 that tracks the full history. Let's have another question. A company is building a customer dimension in Microsoft Fabric Warehouse. When a customer moves to a new city, the business needs to preserve the old addresses for historical reporting, create a new version of the customer record, track which version was valid at the time. Which slowly changing dimension type should they implement? A. SCD type 0, B. SCD type 1, C. SCD type 2, D. SCD type 3. Now think about the answer for a moment and pause the video. I will reveal the answer in 3, 2, 1. The correct answer is C, type 2. Since it is the only one that is able to fulfill these requirements to preserve the old addresses for historical reporting. Type 3 won't work since we are not specifying that we want only the latest addresses to be stored, and we have to assume that we need the entire history. And that is all that I wanted to cover here today. I hope you now understand the differences between those different types of SCDs. And if you would like to continue your learning journey towards getting that DP-700 badge, check out the next video in this series. Now I thank you for watching and see you in that video.